Hi, I'm Chi. Today we'll talk a little bit about squares and square roots. So for the first part, we'll talk about squares. The concept goes something like this. So assuming we have a number, let's just call it 2, right? When we say the number 2 is squared, okay, we will write it down as a smaller number. We call that index. When it's raised to the power, in this case, if it's a square, it means 2, regardless. Okay, the number at the top here can go up to any power. Okay, we can call it power. Okay, and in this case, we'll just discuss on squares. And what these mean is equal. Okay, it means something, and it means you multiply 2 times of it, right? And the same thing will go for 3. It can be any number, square. So we're gonna have 3 times 3. And of course, this is 4 and this is 9. And the reason why we know this is because we have something called the multiplication table. So you can get this from the online, right? It's a downloadable PDF, and you can call it a times table, and we can just simply read the table, okay, where the numbers going vertically down and going horizontally, okay, are 2 numbers, okay, when they are multiplied to each other, and you can get the answer that you're looking for, the number you're looking for. So in this case, for example, we have 3, okay, times 2, you're gonna get 6, okay, where they intersect. Right, the numbers where they intersect. 3 times 2, so they intersect here at 6, so we get 6, right? And the same thing if you have 2 times 3, they intersect here, and yes, it's 6 as well. So this is a very handy table for your reference, but you must know your times table as you're moving towards advanced mathematics. So another thing to take note, and that is interesting, is if you notice that I'm not sure if you can see it, but it's a little bit shaded at the diagonals here. Okay, here, 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 right? And in reality, what we call this is perfect square, and it means that it is a number that multiply itself. So we can have perfect squares. You can have I'm just going to write it down here, 2 squared, that's a perfect square, 3 squared, 4 squared, 5 squared, and etc. So the numbers, and of course this is a solution table. We have 5 times 5, you have 25. 6 times 6, you have 36. 7 times 7, we have 49, right? And it gives us the answer all the way until 25 times 25, which is 625. And this is a very interesting property, and in actuality, squares and square roots will utilize this concept very oftentimes. Okay, back to our problem. So with that in mind, let's start working on the first question. Find the square of 6. So what these mean is 6 squared. So I say that it's 6 raised to the power of 2. And this means it is 6 times 6. And if you look at the times table, it is a perfect square. 6 times 6 is 36. And the answer is 36. Like I said, you got to know your times table, and this will help you to save a lot of time in very basic computation like this. So the next part here is 12, square of 12, and it means 12 squared, and is equal to 12 times 12. And if you look at the table, 12 times 12 is 144. So 144. And the third part here is 20 squared, and is equal to 20 times 20. And if you look at the table, 20 times 20 is 400. So the next part here we talk about is which of these are perfect squares. Like I've mentioned earlier, which of these are made up of the basics that multiply itself. So in this case, we know we just work with the first problem, right? 25, right? 25, as we know, can we express it as a number that multiplies itself? So again, you got to know your times table really well. So 25 here is, as we know, is actually a perfect square, because if you look at your times table diagonal here, you can see that 25 is actually within the shaded region, and it is equal to 5 and 5 multiplied by 5, and with that, yes, this is a perfect square. And for 36, if you look at your table, yes, you can find it. It is the product or the multiplication of 6 and 6. So yes, this is a perfect square. And 40, can you find 40 here? No, we don't, right? So between them is 36 and 49. There is no 40. So this isn't a perfect square because we cannot find a basic number that can multiply itself to return us a number of 40. And then we have 49. So 49, if you can look at the table here, we have 7 times 7. So yes, it is a perfect square. And the last one here is 55. 55 is, if you look at the table here, it's between 49 and 64. So there isn't a 55. So obviously it will have to be not a perfect square. So this is the first part involving squares. Okay, so for the second part, we'll look at square roots. Now, for square roots, it's actually the same thing as square, but it is a root of a square, which means can we break it down into its simplified form? Earlier, we did mention something about we did mention something about 25, okay, being a perfect square of 5 times 5, right? And it can be simply written as 5 squared. Well, square root, we use this root shape, right? This root symbol. And when you say that you square root of something, you kind of get rid of its partner. So in this case, 25 is equal to 5 times 5. And if I want to find the square root of 25, it means I want to find the square root of 5 times 5. And we can say that it actually returns us the number 5. So yes, as you can see that the 25, when you square root it, it returns you the number 5, which is the simplified version of it. And keep in mind that square roots and squares, they work very smoothly when they are perfect squares, or else you have something called non-perfect squares, which we'll discuss it very briefly. So how do we resolve square root of 49? Okay, square root of 49 is actually equal to, so first of all, we'll ask ourselves, how do we, for what two numbers can multiply each other that could give us 49? So if you look at it, you'll see that 1 times 49, 7 times 7. Can 3 multiply by something to give you 49? I don't think so. Can 4 multiply by something to give you 49? Nope. 5? Nope. 6? Nope. 7? Yes, that's about it. 7. So once we reach 7, 8 9, 10, none of them actually work. So we have two versions, and if we use square root of 49 and break it down into 1 times 49, is it more helpful or less helpful? In this case, we can say that it's equal to square root of 1 multiplied by square root of 49. It kind of returns to its original result, so it doesn't really help. But if we look at 7 times 7, we can say that it is equal to 7 times 7, and automatically it just means that the one of the 7s will be removed, and you're gonna get 7. Okay. In actuality, how this thing happens is part of indices, and it is a little bit it looks a little bit like this, where you have square root of 49 is equal to square root of 7 times 7, and 7 times 7 is actually equal to 7 squared, right? And the root is actually the whole entire thing is actually raised to the power of 1/2, and we can treat it like a fraction. 7 squared kind of cancels off, and you're gonna get 7 to raised to the power of 1, which is equal to 7, right? So this whole thing is called indices, and it's a little bit more, I guess, more complicated, right? For now, we don't really need to worry about this because we're working very closely with perfect squares and square roots, so nothing too complicated just yet. Okay, so for 121, you can look at the table. Okay, we have, if you can look for the table, you can already see that 121 is here, and it is the product of 11 times 11, and the answer is obviously 11, right? And 225 is equal to the product of 15 and 15. 225, yep, 15 and 15, and we have which means it's a perfect square, and the answer here is 15. So fairly straightforward. And let's look at the slightly more challenging part. You might be asked to calculate or provide a whole number solution for a non-perfect square. And what this essentially means is you're looking for a solution for a number that doesn't perfectly fit the requirement of a number multiplying itself. So it is no longer gonna be like 3 times 3, 4 times 4, 5 times 5. You'll never find anything like this, and we're supposed to calculate and come up with a whole number solution. So how do we solve this question? Well, what we can do here is we can start off by listing out some multiples of 50. In other words, what two numbers can multiply itself to give you 50? So 50, we can say that 1 and times 50, okay? 2 times 25, right? 3, you can multiply by anything else to give you 50 exactly. 4 as well, 5 and 10, 6, none, 7, none, 8, none, 9, none, and 10, and 5. So it kind of goes back to the original. Okay, so these are the numbers we can actually multiply to give us 50. So which of the following actually gives us a perfect square? Because as you know, perfect squares are very close friends with square roots, and essentially they're very useful tools, and it's about pattern recognition. So essentially we're looking for the numbers that falls in these diagonals here, those that are hatched. And it is very important because it helps us to simplify the problem very quickly. So in this case, the best number here is 25 because it's our best friend, and we know that 25, where the square root of 25 is equal to 5. Okay, it's a perfect square, right? So we can express this in this form. So how do we do it? So square root of 50 is equal to the square root of, within it, okay, we have 2 times 25. And over here, we can kind of break it down into square root of 2 times square root of 25. It has the exact same meaning. So from square root of 50, it has turned into two components that multiplies into each other, which we know this number is equal to 5. Because it's a perfect square, but we don't know this number, right? This number is not a perfect square. And we can just leave it as root 2. So the answer to this question is 5 root of 2. This is an approximate number. You can calculate this by pushing the numbers into a calculator, and you can get a decimal form of this, or you can just leave the answer as 5 root of 2. And that's how you simplify a non-perfect square into a whole number with a square root inside. And this is one way to solve it. So I have attached a PDF cheat sheet in the description below. Feel free to download it if you need some references. I've also attached the multiplication table link if you need to download it for your reference. And if you have any questions or any comments, please drop it down in the comments below, and I'll see you in the next video.